refuse to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Here we are at the U.S. Space and Rocket Center, where we can be fascinated by the story of humans landing on the moon. This is Apollo, the Greek god of sun and light, and the namesake of NASA's legacy program that sought to achieve the impossible. On July 20th, 1969, the world watched captivated by each step as NASA made history. After several more missions, Apollo came to an end, and the moon has remained largely untouched by humans for nearly 50 years. But that is not the end of the story. Apollo had a twin sister, Artemis, goddess of the moon, and her day is dawning. This new generation of astronauts, the Artemis generation, will continue the legacy of Apollo, but it will go further. It will include the first woman on the moon, the first of many. This is the future of American spaceflight. This is the Dynetics human landing system. Welcome aboard. I'm standing here at Dynetics in Huntsville, Alabama. What you see behind me is a full-scale test article of the Dynetics Human Landing System, or DHLS. While this test article will never land on the moon, it is no less critical to NASA's mission. It provides our engineers with insight into how the lander will operate and how astronauts will live, work, and interact with it during a lunar mission.
With the Artemis program, NASA is making history, and the human landing system is a major piece of that story. The Artemis missions will enable sustainable human exploration of the moon. For the first time in history, we're going to explore the ice-rich lunar South Pole, studying billion-year-old ice to unlock mysteries of our solar system. We will learn how to take advantage of the moon's natural resources to build the infrastructure for a lasting lunar base. Artemis is so exciting because this mission is about more than the moon. The lessons of Artemis will provide valuable insight for future habitation on Mars and beyond.
This mission is incredibly difficult, and it requires a very complex and very special lander to accomplish it. So what sets the Dynetics HLS apart?
Our lander is sustainable. Not only are we designing the Dynetics HLS to achieve the 2024 crewed mission, we are designing for future missions too, with as few changes as possible. After our lander safely returns the crew to lunar orbit, it's ready to be reused. Early and ongoing reusability is key to the future of the human space program. Our lander is affordable. We have leveraged flight-proven technologies for the habitat, power, thermal, and other subsystems throughout the design process. And by designing it to be reusable, it will dramatically reduce the ongoing cost of lunar exploration and development. Our lander is incredibly versatile. Of course, the first crewed mission and crewed missions in general are our focus, but in order for the program to be truly sustainable, HLS must do more. Our innovative design enables our lander to transport, deliver, and move a huge range of payloads, from habitats to pressurized rovers, science experiments to in-situ resource utilization demonstration plants. This will open opportunities for government and commercial entities to establish a lunar infrastructure and eventually a lunar economy. More than anything, the Dynetics HLS is different because it's crew-centric. We're designing our landing system with input from former and current astronauts because functionality and ease of use is paramount to us.
The HLS team faces a challenging schedule with the goal of landing astronauts again by 2024. Every day is critical.
This test article is full scale, the same size as the eventual flight HLS. Inside of the crew module is spatially similar to the flight vehicle, with accurate dimensions for inner volumes, sizes of equipment, and layout. We wasted no time in developing this test article. Within 3 months of contract start, it was ready to go.
This is what we call a low-fidelity test article. It's meant to be updated. It's intended to provide a general representation of the system and enable easy, inexpensive, repetitive, and durable reconfiguration of the crew module interior. We'll be fine-tuning it in response to feedback from the crew and our human systems integration team. Also, as the design progresses, we'll build additional high-fidelity test articles. The most important part of this unit is its flexibility. Our human system integration team is already using it to review early designs, including how big things are and where they're located. The beauty is that they can make changes in real time by simply moving items from one place to another by hand. We've built volumetric models of major equipment, clearly labeled for easy identification. Most are standalone units that facilitate simple movement. If this system doesn't work here, let's move it over there.
Crew health and safety are always the #1 priority, and this test article helps the Dynetics team evaluate those critical concerns. But for a mission as complex as landing on the moon, our team must make sure the crew is operating as effectively and efficiently as they can every minute of the mission.
We're using this test article for what we call human-in-the-loop task analysis. Simply put, it means we're looking into things like habitable volume. How much space does the crew need to eat, sleep, and live? Anthropometric accommodation. How much space do the astronauts need to do every one of their many jobs? How can we make those jobs as easy as possible? And how can we make the space as comfortable as possible when they're not working? Placement and orientation of components, stowage, and interfaces. Is everything easily accessible? Have we minimized necessary movements? If something goes wrong, how easy is it for the crew to assess the problem and get access to the solution? Intravehicular and extravehicular activities. Can the astronauts move in and through the vehicle comfortably, safely? How easy and safe is it for the crew to exit the vehicle onto the lunar surface and then get back in again? How quickly can they access the tools they need? How can we efficiently accommodate lunar samples? And will it be easy for the astronauts to deploy necessary experiments?
This iterative and user-centric process ensures the most realistic, most helpful human-in-the-loop testing possible at this stage of the program. It is critical to meeting the schedule with the design that works.
The test article gives the crew and human systems integration team a feel for locations and sizes of windows, hatches, displays, buttons, and hand controllers. The crew gets an early, first-hand experience of personal accommodations. Designers get to see how the placement of seats and other structures impact the interior volume, how the crew restraints and interior mobility aids may be most effective, and how and where various crew interfaces should work. The test article helps the team understand necessary clearances for suit operations. It also gives insight into ingress and egress aids, like a ladder.
The Apollo lunar module enabled our first steps on the moon, unlocking mysteries of a solar system and enabling giant leaps toward future spaceflight. This remarkable spacecraft remains the only crewed vehicle to land anywhere beyond Earth, until now. The Dynetics HLS is similar in size to the Apollo lunar module, but is truly a next-generation lander. We designed the Dynetics HLS with input from former NASA astronauts, developing a low-slung design that maximizes safety and situational awareness for the crew. So, what makes Dynetics different? Dynetics has deep roots in the space community and a history of a strong collaboration with NASA.
Dynetics is a Huntsville company founded in 1974 in the wake of the success of the Apollo program. When it came time to put astronauts on the moon, America looked to Huntsville, Alabama. That love of exploration, of doing more, of going further, that is what fuels this town. The pride in the American space program, the excitement here, it's palpable. Huntsville is called the Rocket City because that is our heritage, from answering the challenge of Sputnik to launching the Redstone rocket that put the first American astronaut into space, to asserting American space dominance with Apollo. We changed the game. It was brilliant engineers and scientists in Huntsville who put those men on the moon, and their work here inspired our entire nation. Now, Dynetics is a part of this story. We're part of writing the next chapter, returning to the moon in an entirely different way to continue American space innovation.
Dynetics has been solving complex problems for more than 45 years, and we are thrilled to have Dynetics as part of the Leidos family. We are fully committed to this endeavor, and we are proud to join this effort to launch American astronauts from American soil and return them to the moon for the first time in nearly 50 years. This is an absolute national effort. We have assembled a team from across the entire continental U.S., from 19 states and counting. Our team brings a global perspective with decades of past performance building and flying space systems for NASA and other international space agencies. This program is much broader than a new lander to get humans back to the moon. Our lander is an investment in our nation's future, not only as a cornerstone for a real space-based economy, but also to protect America's technological position as a global leader, to ensure our national security. America's vision and the entire Artemis program is truly innovative, providing the building blocks to revolutionize sustainable space travel and bring future deep space exploration within our grasp.
What is next for Dynetics? Our nationwide team is working tirelessly to deliver the Artemis astronauts to the moon by 2024, continuing NASA's legacy.
One thing is for certain, our mission is NASA's mission. Exploration is in our DNA, and we view this program as core to our legacy. The Dynetics human landing system will be built right here in Alabama, and we are truly America's team.
This is the future of American spaceflight. It's history in the making, and we are ready to deliver on our commitments.
Be a part of America's mission to the moon. Learn more at Dynetics.